Hey math kids, I'm here to help you with your 6.2 homework. We're going to start with problem number 1. The square root of 8 times the square root of 32. I'm going to show you two different ways of doing it. I'm going to do the square root of 8 as 2 times 2 times 2. And I'm going to do the square root of 32 as 2 times 2 times 2 times 2 times 2, or 2 to the 5th. This is 2 to the 3rd. Okay, remember that the index here is a 2. When there's nothing inside the square root box, that means a 2. And so since the index is 2, that means I'm going to pair off every set of 2 that I find. So I can take out 1, 2, and I'm going to leave the square root of 2 in here. I can take out 2 2's, and there's a square root of 2 left here. Right, then this becomes 2 square root of 2 times 2 times 2 is 4 square root of 2. And then I can take this and I can multiply these two numbers. 2 times 4 is 8. And I can multiply what's in the root. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2 times 2, so I can take out another 2. So it is like saying 16. Another way to do it, which might be simpler, is to, here's the original problem, multiply these two and put them under one big square root. So this becomes square root of 256. The square root of 256, we can say that that's 2 to the 8th, or 2 8 times. 1, 2, 3, 4, 5, 6, 7, 8. The fact that this is a square root means that I can pair off by 2's, and I can see that there's 4 sets of 2's, so I can take out 4 2's. 2 times 2 times 2 times 2 is 16. So either way, you get the same answer. We're now going to do problem number 2. This is the 4th root of 8. We're going to rewrite 8 as 2 times 2 times 2. And then this is the 3rd root of 32. And 32 is 2 times 2 times 2 times 2 times 2. That's 2 to the 5th. 8 does not have a 4th root because there's only 3 2's in the square root. There are, however, one set of 3 2's, so I'm going to take out a 2. And I'm going to leave a 4 in the box. This is square root of 8. What I can do is I can merge these two numbers. 8 times 4 is 32. There's a 1 here. I'm going to put that in a different color. So whenever there's nothing outside of a root, that's a 1. 1 times 2 is 2. So we have 2 square root of 32. 2 square root of 32 can further be simplified. The 32 is really 2 to the 5th, so that's 5 2's. 1, 2, 3, 4, 5. And since the index is 2, I can pick out 2 sets of 2 here, and I can bring them out. Here's the original 2. Here's another 2. Here's another 2. And there's a square root of 2 left in the root. So all in all, our final answer is 2 times 2 times 2, which is 8 square root of 2. There's an alternate way of doing this problem. I'll do it in a different color. And that is to multiply 32 by 8 and to try to merge these two. The problem is that one is a 4th root and one is a 3rd root, so those cannot be combined. So the only way to do this problem is this original way that we did it, and the final answer is a square root of 2. We are continuing now with number 3. They want the cube root of 9. 9 can only be broken up into 3 times 3. So there is no other simplification for the cube root of 9. Then there's the cube root of negative 24. We can break down 24 into 12, and then 2 goes into 12 again 6 times. Then 2 goes into 6 3 times, and 3 goes into 3 once. The cube root of 24 then would be 2 times 2 times 2 times 3. We see that we have 3 2's. The 2 can come out. Cube root of 3. This is the cube root of 9 still. And then what we can do is combine these two roots, and we have 2 cube root of 27. 27 can be broken down into 9. 3 goes into 9 3 times, 3 goes into 3 once. So 2 cube root of 3 times 3 times 3. The index is 3. There's 3 3's. The 3 can come out. There's a 2 already there. And there's nothing left, which is the same thing as saying that there's a 1 left. So our answer is simply 2 times 3, or 6. One thing I need to mention is that it was the cube root of negative 24, so these are negative 3's. So this is a negative 3, so your final answer is negative 6. There is another way to do the problem. Cube root of 9 times the cube root of negative 24. And that is to multiply the 24 times the 9 and combine them all in the same root. 24 times 9 is negative 16, negative 216 cube root. The reason we can combine those two problems is because the indexes are both 3. We can break down 216. We can divide by 2 and we get 108. We can divide by 2 again and we get 54. We can divide by 2 again and get 27. Then we can divide by 3 and get 9, by 3 again and get 3, by 3 again and get 1. So the cube root of 216 is 2 times 2 times 2 times 3 times 3 times 3. And we can take out a pair of 2's and a pair of 3's. So that's 2 times 3, which is 6. Continuing now to number 4. Number 4, again, we can do both ways, but I think we should try just combining the roots since they're both having an index of 3. 16 times 4 is 64, so we have the cube root of 64. That's the 4 times the 16. I can break down 64 by dividing it by 2. 2 goes into 64 32 times. I can divide by 2 again and get 16, by 2 again and get 8, by 2 again and get 4, by 2 again and get 2, by 2 again and get 1. So I have the cube root of 1, 2, 3, 4, 5, 6 2's. 4, 5, 6. My index is 3, so that's 2 sets of 3 2's. I can take them both out, and so my final answer is 4. Continuing on to number 5. Again, both indexes are the same. I can combine the 5 times the negative 25, and I'm going to get a positive 125, and it's a cube root. Let's go ahead and break down 125 by 5. 5 goes into 125 25 times. 5 goes into 25 5 times. 5 goes into 5 once. And we stop there. So 125 can be rewritten as 5 times 5 times 5. There's 3 sets of 5 like the index. And so we can take it out once. The answer to number 5 is 5. Moving on to number 6. Number 6, we can do it both ways. If you multiply 50 by 75, you get a very big number, 3,750. So this one I think we should do separately. The index here is 2. They're the same index. So we're going to try to do 50 first. If I split up 50 by 2's, I get 25. Then I have to go by 5's. 5 goes into 25 5 times. 5 goes into 5 once. So 50 can be rewritten as 2 times 5 times 5. There's 2 sets of 5. Remember the index is 2. So I can take out a 5 and that becomes 5 square root of 2. Let me do 75 in a separate color. 75 can be split by 5's. 5 goes into 75 15 times. 5 goes into 15 3 times. 3 goes into 3 once. So 75 can be written as 5 times 5 times 3. I can take out a set of 5's, and that is 5 square root of 3. I now have this part from the square root of 50. I have this part from the square root of 75. I can combine these two 5's. 5 times 5 is 25. And then, separate color, 2 times 3 right here. Under the root, that's square root of 6. And so my answer is 25 square root of 6. The other way would have been to combine square root of 50 times square root of 75 into one humongous root. 50 times 75 is that big number we talked about, 3,750. 3,750 can be divided by 2 to give 1875. That can be divided by 5 to be 375. That can be divided by 5 again to get 75. That can be divided by 5 again to get 15. That can be divided by 5 again to be 3. That can be divided by 3 to get 1. So 3,750 can be rewritten as 2 times 5 times 5 times 5 times 5 times 3. The index is 2. So therefore, every set of 2, we can take out 2 5's and we can leave a 6. The 2 times 3 inside. And so we get 25 square root of 6, which is the same answer we got the other way. Proving that no matter which method you use, you will get the same answer. Let's go ahead and do some problems with letters. So we essentially do this the same way, except that we're going to split this up into the number and the letter part. It is a cube root. We're going to split up 32, which is the number. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. 2 goes into 2 once. So the 32 can be rewritten as 2 times 2 times 2 times 2 times 2. 5 times. We're looking for a cube root, so we're looking to take out every 3 2's. Take out a 2, you're left with 2 square root of 4. Now, this part is separate. This is the letter. So the cube root, of a to the 5th, it's like having 5 a's, 1, 2, 3, 4, 5. Again, being a cube root with an index of 3, we're looking to take out every 3 a's, so we can take out 1a, and we're leaving a square inside of the root. And from this part, we have 2 square root of 4, and we're just going to put this entire thing together. The 2 times the a is 2a, and inside the root we have 4a squared. Because this is a cube root, there is nothing more we can do here, because 4 could be simplified if it was a square root, but we're looking for sets of 3, not sets of 2. So this is the simplest answer that we can have. Moving on to number 8. These are fun, aren't they? We're looking for a fifth root of negative 32, x6, y7. We're going to take the number first. We're going to break down the 32 by 2. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. 2 goes into 2 once. It's an odd root and it's negative, so that means that negative 32 can be rewritten as 5 sets of negative 2. 1 2 3 4 5. It's a fifth root, so every 5 we can take out 1, so we can take out a negative 2. Now let's deal with the x to the 6. X to the 6 is 1 2 3 4 5 6 x's. We can take out 5 of them. We can take out 1, so it's negative 2x square root of x. And then this is y to the 7th. That's 7 y's. 1 2 3 4 5 6 7. It's a fifth root, so we can take out 1 2 3 4 5 y's. We can take out a y once, so it's negative 2xy, and what's left in the root is an x and 2 y's, which is y squared. That was a little bit of work, but worth it. Moving on to number 9. It is a cube root of 81. 81 we can break down by 3. 3 goes into 81 27 times. 3 goes into 27 9 times. 3 goes into 9 3 times. 3 goes into 3 once. So 81 by itself, just the number, is 3 times 3 times 3 times 3. It's a cube root. We're looking for sets of 3 then. We can take the 3 out once and leave a 3 inside. Now this x, there's 3 of them. And we're looking for a cubic root, so we can take out 1. So your answer is 3x cube root of 3. Number 10, again, it is a cubic root. We can break down 54. 54 divided by 2 is 27. Divided by 3 is 9. Divided by 3 is 3. Divided by 3 is 1. So just the 54, the numerical part, can be rewritten as 2 times 3 times 3 times 3. We're looking for sets of 3. So we take 3 out once. 3 cube root of 2. Now the y's. The y's I'm going to do in a different color. There's 10 of them. 1 2 3 4 5 6 7 8 9 10, and I'm going to extend this square root. It's a cubic root, so I can take out every 3. So 1 set here, 1 set, and 1 set. I can take out 3 y's, or y cubed. So I'm left with 3y cubed. What never went away is the 2 and the y. So what's left inside the root is 2y. Your final answer is 3y cubed square root of 2y, or cube root of 2y, I should say. Okay, we're going to do one last one. There's one down here that I'd like to try with you, and that is number 19. This is a division problem, and the index here is 2, and the index here is 2 also, which means we can combine this whole thing. So if I rewrite this, it's like rewriting 48 over 3 x cubed xy squared. I can put the whole thing together under the same root. 3 goes into 48 16 times, and then we have 3 x's appear, x times x times x, and then on the bottom we have 1x and then y times y. You can see that one of these x's cancel, so what you're left with is 16x squared over y squared, and it's all under the root. Alright, I can break down 16 into 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 twice, 2 goes into 2 once. I can break down this root then into 2 times 2 times 2 times 2 times x over y times y. That means that I can take out a pair of 2's here, another pair, a pair of x's, and a pair of y's. So I can take everything out once. I can take out a 2, an x, and then divided by y. So my answer is 4x over y. Alright, math kids, I've done 11 problems with you. There's 19. You get to do 8 more. Make your work neat and clear, and follow along on the problems that we've already done. Impress me with your work. Go slow, be neat, and I'll see you next time. Alright everyone, I've done the first 10 with you, and now you get to do the last 9 and impress me. Make your work neat and clear so I can see what you're doing, and I will check in on you. Send me an email if you get lost. See you next time.